So let's start the presentation now. So again, good morning, everyone. And this is Alan from Chroma, Taiwan. Today, we are talking about the topic is regarding the battery cell and how to screen the risk of electrical short in lithium-ion battery cell. So first, the EV explosion occurs frequently, and but we know it's happened. But how to improve the lithium battery safety? Here is a short video. It's recorded on this year, May 8th, and this happened in mainland China. This happening during the charging. So please take a look. So we know the internal short circuit of the cell could cause the explosion and fire. And we also know this result in excessive flow of electrons within the cell. And it will increase the dual heating and also the internal temperature. And then potentially this will lead the thermal runaway. So, but in production line, there are several checkpoints to test during cell assembly. But do you know why does the cell still burn even past the information process? During the information process, we measure a lot of parameters, but it doesn't work. And again, why there are several cases indicate the cell get burned after selling. Why the potential dangerous products still shipping to the end customers. And the final question will be why the insulation test in the jelly roll cannot detect the defect in head of a process. So today we are trying to give you some idea and try to answer those questions. And first things, why the regular iometer or hipot tester cannot detect the abnormal battery insulation completely. And first, we want to tell you this very important idea is insulation test should be check of the distance between electrode, not the resistant value measurement. And we are talking about why. Here from the left-hand side, there's a graph. We assume there's a particle in every case, A, B, C, D, and E. So we know in case E, there will be immediately short. So all the tester or the meters can catch out this defect. However, in B, C, and D, how do we catch them? How do we judge them? If we use the regular iometer, probably we will think this kind of a defect product will be pass, will be a good product. And that's why we suggest our customer to increase the test voltage. On the right-hand side will be the breakdown voltage of the air versus the gap distance. You can see in this case, we assume the separator is about 12 micron. and there will be different height of a particle. And the gap between the cathode and anode will be showing on the red color. So if we check the table here in right hand, we can see, in case A, the 12 micron, probably you have to test over 500 volts, even greater than that. In the case B, the gap is about 9 microns, so it's about 450 volts. In the case C, there will be a 6 micron, so it's about 380 volts. And the case D will be 2 micron, it's about 350. So we know most of our customer will think case B, C, and D will be NG product. However, if you set your test voltage is below 350 volt, probably it's hard to detect this kind of defect. That's the example. If we use most of IR meters use about 100 volt or up to 250 volt to do the IR test, and you can get the good result. The result will be all passed, both on 100 volt or 250 volt. However, the burrs, you can see here, if we apply a higher voltage, okay, and on this kind of a subject, then the burr shrink after electrical discharge and left a melt hole on the separator. This kind of burr will expose and become a potential dangerous battery. And we will show the animation later. Okay, so some people will say, if we increase the test voltage, how about the 600 volt? So we also do the similar test at the 600 volt, and we also get the IR passed result. And please check this kind of, there's an animation here. So this is kind of a burst over here, and the separator will be a 12 micro. And we apply, for example, 600 volt, and what will be happen? According to the breakdown voltage of air, we know if we apply the 600 volt here, and there will be a discharge happen here in this kind of defect. Then the discharge will cause the separator melt because of the heat. So this gravity will become the melt hole, and we assume there will be an air. And then the burrs will shrink. So that means if you apply the same voltage in this kind of sample, you will get a passed result because the air also provides a good insulation. Okay, Sling asked the question, let me ask you. Sorry, somebody is asking the question. So I will answer the question later, okay? So let's go start the presentation. So during the test, the measurement time will be, minima will be 20 milliseconds. Okay. So this kind of discharge will happen immediately if you apply the right voltage. So the second thing we will try to introduce will be the inflat of the anode. So if we, even without the external force or poor BMS design, lithium battery may get burned or explode during the regular charge or discharge cycles. That's because the anode material inflate during the charging process. And moreover, it will keep inflating, repeat again and again. During the report, we can see after 10 charge cycles, and the graphite material on the copper foil could inflate up to 24% of its original thickness. And we are trying to explain why the battery or this kind of defect battery will pass the in-house test and get short, internal short after shipping to the customer. And there's two spurs, two different cases. In the case one, you can see there will be a strong burst and very long. And after the second time of charging, and you can see the anode will reach the particle and get short. Then probably this kind of, in case two, this kind of defect product will be monitored and captured in-house. And how about case two? If the particle or the spurs will be shortened, then they will be not captured in-house. This kind of defect does not be detected before the injection of electrolyte. It will not be captured by RES method. Many battery manufacturer doing the RES method measure the delta voltage in formation process. The reason is the distance between the electrode has no change. And we can know if the distance will be no change and how to make it short. So this can explain why the lithium battery still get burnt after even being sold to the end customer. And in the right-hand side, we have a short animation. So this is the first charge and discharge. And second time, and the third time. You can see this example, you can see the sample is getting short at the third time of charge. So you can see if there's a melt hole, it's not separated. So the burrs will reach the anode side directly with no any protection. So it's really dangerous. So that's why we call it a potential dangerous product. And this kind of product cannot be detected by the regular IR test, even you increase the test voltage. So what's the correct way, what's the right way to doing the insulation test for the dry cell? For the below chart, you can see during the test, probably we use the 4 different timing. First is from charge, dwell, to the test, and then discharge. And most of IR tester is doing the test during the test time only. So how about anything happen during charge time? How about anything happen during dwell time? Can they detect anything? So The regular IR meter or hipot tester can only measure the average value of the leakage current within a specific time interval. So it may cause missing the detail of voltage change and leakage current. So people will think this kind of defect is not acceptable. However, they can do nothing because the regular IR test only provide the test time to measurement the value. And most IR meter only measure the data during the test time interval, not the entire cycle. So you see the chart before, the IR pass at 600 volt. So why is a potential dangerous sample? This is the same graphic, okay, we test before, and you cannot see the detail, right, before. But if we enlarge, if we zoom in the voltage, you can see there will be a little bit drop here. It's about 7 to 10 volt drop here. And during the constant voltage status, it's hard to judge from the voltage drop. However, if you monitor the leakage current, you can see there will be the current increasing over here. But this only happens in the dwell time, not the test time. So, of course, that regular IR tester cannot capture this kind of defect. So what we suggest, we have suggested two things. The first thing will be we monitor the entire process, including the flashover detection, and also the leakage current monitor. So we suggest customer to check both the voltage and the current in the entire process. The IR test indicate is insulation resistor tester. So it's normally used in the battery manufacturer. So we also suggest where do you use this kind of test in the battery production line. There will be several type of battery cell, including can battery, pouch cell, and special pouch cell. We have a chart over here. You can see. Here's the example usage in production line for the can cell. We suggest the manufacturer can do the inspection after welding, and also before the filling the electrolyte. For the pouch cell, we suggest customer to do the check for the single pair, and then after the stacking, they can also do the inspection check. And they also, before the filling the electrolyte, they can do it again. So the example here is we suggest our customer to use the station to test the IR. And here's a Chroma 11210 battery cell insulation tester. We provide up to 1 kilovolt. And the maximum charge current will be 50 milliamp. And the maximum speed is 20 milliseconds. It's compared to other tester, it will be really fast. And we also provide the BDV function. And most importantly is we support a contact check both in pre-test and post-test. And as we suggest our customer, we provide a fully automatic test, including charging, dwell, and the test until the discharge time. And also, we provide the PD detection. So that's we call the voltage drop or the faster changing on both the voltage and current. And also we have the analyzer function. So we have do the quick summarize here. So the first thing will be insulation test in jelly roll should be a validation of the distance, not the resistance value. That's very important. According to the breakdown voltage of air, the test voltage of effective inspection should be above 350 volt. It depends on what kind of material you use and what is the distance, what's the thickness of the separator, and also what's the material of the separator, and also what's the material of the anode material. And for pouch type cell, also you have to consider the strengths you push on the cell. That will be all change the insulation distance. So that's why we suggest a customer to use at least 350 volt to do the test. The anode material inflate during the charging process, and it will repeat again and again. So that's explain why in many cases it's this defect product is delivered to the end customer, and once they reach the anode thickness, reach the particle, the whole battery cell getting short immediately and get burned. When the burst or particle on the separator do not cause an immediately short circuit, but it is sufficiently to reduce the insulation distance. So that's we explain the particle size may, if you apply the regular voltage, lower voltage, you cannot detect anything. In further, the burst of explodes and become a potential dangerous product. You can see the particle may cause the melt hole, and all the burst or the particle will explode without any protection. And the entire process of the partial discharge detection and the leakage current monitor can provide the better test method. So if we, is anyone have any question? I see. Chart to test the voltage versus insulation. Oh, okay. Yes, we do have a chart. Okay. We know the separator have many hole, the porosity. So we assume there's air in the separator. So we use the breakdown voltage of air versus gap, for example, here. The dwell time will be set, depends on the what kind of a cell, what the capacitance of the cell, and what kind of a material. So we do provide a suggestion. We provide a kind of a material to customer to let them know what kind of setting we prefer recommend setting to customer. The test voltage depends. So we support up to 1000 volt. However, some of our customers use 350. Some of our customers use up to 800 volt. It really depends. As we said, the insulation test is measurement the distance between the electrode. So the thickness of the separator will be different in every customer, in every case. Then there will be probably different test voltage will be applied. Thinner separator will use the lower voltage. In the other way, the thicker separator will use the higher voltage. Yes, the equipment we introduced today is usually to do the test before the electrolyte filling. Yes, only before the electrolyte. Can import the test video cost.
Hey, Alan, it might be helpful to read the question and then answer it just so everyone knows what question you're addressing.
Oh, okay. So Jeff is asking, do this test method only apply to the battery before electrolyte is filled? Yes, the answer is yes. And after filling the electrolyte, we cannot apply the higher voltage, right? Most of the Lithium batteries about 3.7 to 4.2 volt. So in that kind of voltage, we cannot find any defect. Is the gap, Harry is asking if is the gap voltage relationship the same for all known Lithium battery chemistries? I didn't do all kinds of Lithium battery. However, we focus on the battery used in the electro vertical. So I tried the MWC, and I think I tried most of the MWC battery. I don't have many samples I can do, but according to our theory, I believe this gap test voltage relationship can apply to all kinds of Lithium battery. Yes. Okay. Craig is asking, are there any difference between testing with AC or DC voltage? So let's see a chart over here. We suggest to do the test, we're using the DC to do the test. There are two major reasons. The first would be DC is charging, it's more fast. And also we can, let me see. You see, if we use the constant current for the DC, if we use the DC, we can monitor and easily capture the faster changing of the voltage and both the current. So Erica is asking, how does a failure showing on your screen? So in here, here's the screenshot of our meters. So for the regular IR or LC meters, we also can measure the value. However, if you turn on the PT function, then we can monitor both the VPD and IPD. And VPD means the voltage, faster changing of the voltage, and IPD means the fast changing of the current, and also how many times happen, such as this one, like how many voltage drop, how many times, and we also provide the maximum level. The level will be provided from 1 to 99. The higher level means the higher discharge. The lower value means lower discharge. And for the Ruben, yes, can the device perform a test with a CC of 50 milliamp at 1 kilovolt? Yes, yes, sure. The field is asking, does test voltage and dwell vary with cell capacity? Yes, it will be for the different, let's see, okay, for the test voltage, it depends on the distance between the electrode. And for the dwell time, yes, it will be changed, depends on what's the capacitance you use. Okay, so there's no question. We start. Now it's midnight in Taiwan, so I don't have a demo machine. However, we will record a video and we would like to show you. Here's the equipment we use for the video. And 11 to 10 with a PT analyzer card. And the test sample will be two kinds. And the first will be the separator. This separator provided from the Japanese maker. And also the jelly rolled. Let's start the video. Here, so we disable the PD function, and you can see there will be the abnormal voltage drop. However, the test is showing pass. If we enable the PD function, we can easily capture this kind of failure. So we can, then the second part is a PD recovery phenomenon. This is the first time trigger at the 350 volt. You can see the screen shows a PD fail. And the waveform shows the voltage drop and the leakage current. And if we apply the same voltage and do the second trigger, you can see it passed. The same sample, it passed. So that's what we call the potential dangerous sample. I know this video is really quick, then we do a summarize here. In the first part, we want to show you guys the advantage of our PD function. So you can see the tester, if we disable the PD function, you can see the tester judge the sample is passed. However, the waveform capture the failure. Again, if we enable the PD function, you can see we can capture the failure on the tester easily. And the second part of the video is showing the PD recovery. Do you remember before in the previous slide we introduced, if we apply a certain voltage, a higher voltage on a defect sample, there will be the melt hole. So the melt hole becomes a good insulation material. It's not a separator, it's an air itself. However, the air can provide enough insulation distance. So that's why if you trigger the first time, you can see the PD discharge and the melt hole coming and the particles shorten. However, if you apply the test with the same voltage, second time, you can see the PD pass. And both the waveform on the voltage and current is passed. No, nothing abnormal. And we also find out the melt hole after the test. So you can see we actually put some particle before the test on the separator. And they after the test, we can find out there is actually the melt hole on the separator. So I think that will be all today. So I will start to answer the question. Okay, I will try to answer the question one by one. So Slim is asking, normally the dwell time should be not be less than 1 minute. I would say most of our customers, if we use the 11-10 in the production line, it's consumer time. So I know many customers using the dwell time between millisecond to 100 milliseconds. Yeah, it really depends. But I do know the Hall test is around is below 1 second. And even the some customers use 11-10 to set the Hall test below 50 milliseconds. Okay, I think that be depends on all the material and all the sample. And we use the term PD in is, let me see. Okay, we use the chart over here. Why we use the term PD is a partial discharge. So it's similar as the flashover, but I assume PD is easier to understand. So the PD means the fast changing of the voltage or the current. So does that one do does that the voltage and the will vary with the cell capacitor insert? Okay, I think. Okay, I think. Okay, I think did I answer all the question? Oh, Rubin asked, are there any consideration to make when using the device for capacitor testing. If you are talking about, for example, MLCC, and I think no. However, the spec of 11210 is up to a test voltage is up to 1 kilovolt. So if you're using a plastic capacitor, probably it's not enough. But for MLCC, for most of the battery, is enough. Consideration of what high voltage polarity to use both. We can do both. Yeah, we can do both, Phil. So the positive of our tester and the voltage of our tester is floating. So it doesn't matter if you use a high voltage in positive or the negative end. Yeah. So we know we know there's a lake of our current technology of our regular IR tester. So that's why we designed 11210 with a very unique features. So we would like to introduce this kind of technology or the theory to all the battery maker and also the people who concern their battery safety. So if there's no question, I will provide my email address to you. So you can email me anytime if you have any question. Oh, thank you. Thank you, everyone. Thank you. Thank you. Bye.
Thank you, Alan. Take care.